There we go. Okay, label A, B, C, and if you want to use patty paper, trace it and then flip. So I'll just use my patty paper for a demonstration. It probably won't line up perfectly. No, it won't. So you would take it and you would literally flip it and then graph your new points. If you want to do that, that's great. If not, that's fine too. I know that when you reflect, you can also just count. You're reflecting across the x-axis, so I go, it's 1 away from the line of reflection. So I go 1 the other direction, so I label that A prime. B is 2 away, it's got to be P 2 the other direction. C is 6 away, it's got to be 6 the other direction. Connect your lines, please, or connect your dots to make you a triangle. Okay, what we're going to do next is see what's happening to the coordinates. So hopefully you have it labeled A, B, and C, and you have it labeled A prime, B prime, C prime. I would like to see this reflection across the x-axis on your paper, and once I see it from everyone, we'll talk about the coordinates. A, B, C. So A is at, we're going to write our original points. A is at 5, 1. B is at 1, 2. And C is at 4, 6. Do we agree? And we moved it to the blue figure, so I'll put a blue arrow. Okay, let's write our new points. 5, 1, what did that turn into? 5, negative 1. Oh, wow. Okay, 1, 2 turned into 1, negative 2. And 4, 6 turned into 4, negative 6. Okay, so could someone raise your hand and tell me what's happening? One. There's so many good things. I know there is. Let me hear from one person. Tori, say it loud.
The X's, or the Y's getting negated.
Right. The X stays the same, but the Y gets negated. It changes signs. So our rule, and this is important, so I would like star it. Our rule for reflecting over the x-axis is that the original point, xy, and put your little arrow, goes to, x stays the same, because it's flipping over the x-axis, but the y is negated. So in words, what this means is you negate the y, so if it's positive, it turns negative. If it's negative, it turns positive. Yes, I do need you to know this. And if on like a quiz or a test, you just forget the rule completely, you could get out some graph paper and plot some points and try it. And you'll probably discover the same thing. So it's not necessarily something you have to memorize as long as you can discover it quickly. Okay, can you please do the reflection over the y-axis if you have not already? So reflecting over the y-axis, and I'm going to label that with double primes. So since B is 1 to the right, it's going to go 1 to the left, and I'm going to label that B with 2 apostrophes to mark it as double prime. C is 4 away, goes 4 left. A is 1, 2, 3, 4, 5, so it goes 5 left. If you want to use patty paper and flip the patty paper over the y-axis, that works as well. So I did mine in black, the black letters. And once again, we are going to write out the old coordinates and compare them to the new coordinates. So old coordinates are still 5, 1, 1, 2, and 4, 6. And now let's see how they change. Alex, what is A double prime at?
Negative 5, 1.
Okay. Brennan, what is B double prime at now? Okay, and Liz, what's C double prime at?
-4, 6.
Okay. What do you notice? The x turns negative. It gets negated. And so our rule is that xy goes to negative x, comma y. I remember these, and this is because it's negating the x. So you look, you have all negatives, -5, -1, -4. I remember this by saying, okay, if I'm flipping over the x-axis, then the x stays the same. If I flip over the y-axis, the y stays the same. Okay. We're going to talk about reflections in general now, and then we'll do some practice with graphing lines that I need you to know how to graph today. Okay, reflection is a transformation that uses a line like a mirror image to reflect a figure. I think we're probably familiar with this, because we probably have done transformations before. It flips a figure over the line of reflection to create a mirror image. So your line of reflection, if the point is away from a line, then if you connect the points and compare it to the line of reflection, it should be perpendicular. If your point is on the line, then it's going to stay there. What we're going to do now is graph these 4 lines, because sometimes we forget things from Algebra 1. And so we're going to review how to graph those correctly, so you graph your reflections correctly today. Okay, if you look over on the whiteboard, it says Hoi Vux. Right over here. Turn and look. Wow. Okay, so we're talking about this in algebra right now. Horizontal lines have a slope of 0, and our y equals a number. So if it's y equals -2, it should be a horizontal line. Vertical lines are undefined. They're straight up and down. And slope dude says undefined. So he falls off a cliff. And our x equals a number. So x equals 5 is going to be a vertical line, up and down. So let's do the first one. X equals 5. Do it in red. I go to my x-axis, which is here, and I go to 5, and I plot a point. The only way it makes sense to draw a line would be up and down, because otherwise you're going to draw it on the axis, and that doesn't really make a whole lot of sense. So draw your line straight up and down. That way, x is always at 5. That's the line that represents always being at 5. And since you probably have one color, I would label this x equals 5. Because you're going to have 4 lines in the same graph. Okay, I'll do y equals -2 in blue. Go to your y-axis at -2. Put a point. Can you show me with your arm which way does it make sense to graph the line? Vertical, horizontal. Yeah, flat line. Otherwise you're going to go on the axis, and that doesn't make a whole lot of sense. So draw yourself a horizontal line through -2. And since you have one color to write in, label it. Y equals -2. I'll do the next one in black. Y equals x. What number's in front of x right now you can't see? A 1. And what can I add to this equation that wouldn't change it? Like, what could I have my y-intercept be? 0, because I can go plus 0. So it has a slope of 1 over 1. It goes up 1, right 1, up 1, right 1, up 1, right 1. And it starts in the middle at 0. So it's going to go up and right, over and over, and then reverse it, down and left to get the other points. This is the most basic kind of line. Y equals x, goes through the middle, has a slope of 1. So we call our parent function for linears, because every other type of line comes from that. And please label it so you know this is the line y equals x. Okay, the last one is y equals negative x. What number's in front of x right now? You can't see? And 1, specifically a negative 1. So y equals negative 1x, and you could do plus 0 again. So I'll graph this in green. Sorry, it's kind of hard to see. So it's going down 1, right 1, and it starts at 0. Oop. It should be a nice negative line. And we'll graph that, label it as negative y equals negative x. With 4 types of lines, I need you to know how to do. We're only going to do 2 more examples, and we'll save the rest for tomorrow. If you want to go ahead and graph A, B, and C on both graphs, you can. But don't reflect it yet because I'm going to change what we're reflecting over. So we're instead going to reflect this over y equals negative 1 and x equals positive 1, because otherwise it's going to go off the grid. That's my fault. So can you please change that and go ahead and graph A, B, and C. The 2 triangles are going to be different, so don't assume that they're the same. The 2 graphs are different. And make sure you label them A, B, C, because when we reflect, we have to label A prime, B prime, C prime. Okay, so on your homework, it's going to be a little tricky because you're not going to be able to graph on your screen necessarily. So if you feel like you need to print out your homework to help you out and then do your final work on the screen, that's fine with me. Do whatever you need. Because these kind of ones on your homework, I found students had kind of some trouble with. What I do first is I always graph the line of reflection. So y equals negative 1. Is that horizontal or vertical? Show me with your arm. Which way is it going to be? Flat line. Going through y equals negative 1, and I usually draw a dotted line because it's not actually part of the reflection, it's just what you're reflecting over. A is on the line of reflection. Where's it going to end up? Right there. So it's not going to move, but we're still going to label it A prime. C is 2 below, so we're going to go 2 above the line and label it C prime. B is 1 below, let's go 1 above. And connect it. The next one is at x equals, reflecting over x equals 1. So that's a vertical line that goes through the x-axis at 1. Reflect over that line and make sure you label your points. check it after you're done and make sure it's a mirror image.